Oh, I've already started. I'll edit that. Because sometimes it comes up with like, oh, how do you want to record it? So I'm like, okay, I'll make sure to click the right one. And no, it's just gone for it. But there we go.
It's keener than you are.
Anyway, so hello and welcome to our latest episode in the World of Work interview with series. Today, I'm Joe and I'm going to be talking with Jeremy here.
Hello, hi there. My name's Jeremy. I'm studying computer science at Loughborough University. So I've been learning loads about artificial intelligence, artificial neural networks, learning programming languages, and lots of different things that you get to learn on a computer science course. And I'm here to talk to you about it a bit today.
Thank you for that, Jeremy. That sounds very interesting. A lot of stuff that's kind of over my head. Computer science was never really my jam. My brother, he's sort of really into it and he tries to explain it to me, but it just goes over my head. But hopefully we're going to have loads of people that will be interested and want to know all about it. So yeah, thank you for sort of explaining all that for us. But in terms of your journey into getting to the course at Loughborough University, what was kind of the process? Why were you interested in it, and sort of what subjects did you take in order to get to where you are?
Well, I mean, it's funny that you mentioned computer science isn't your jam, because for a very long time, it wasn't my jam either. It wasn't really something that I'd considered as a career path, as a university path. I was initially meant to be doing mechanical engineering because I did maths, I did physics, and that just seemed like the kind of clear direction to go in. But I got a bit ill during my A-level year, so I had to sit my exams in hospital. And Loughborough University offered me a foundation year course, which was basically there to bridge the gap between what I missed out during A-levels and what I need to know for my first year course. And the way that the foundation year works at Loughborough is it's a relatively general course between kind of science and engineering. So it'll fill you in the things from maths A-level, physics A-level, just some engineering fundamentals, and also some programming fundamentals. So that's when I actually decided that I think mechanical engineering might be the wrong path for me, and computer science is absolutely fascinating. I'd always had this sort of thought from when I was a young kid of when you move this mouse, how does the computer know to kind of move these pixels on the screen across? And I'm finally learning how to do that. I just hadn't thought that I could actually learn to do that at university. So when I did the introduction to programming course, I really enjoyed it, and I put in a request to the university to see whether I could change onto the computer science course. And they said, if as long as you achieve these certain grades, and then we'd be more than willing to. So that's just one of the paths that people can take onto the computer science course. A lot of people on my course did a computer science A-level, but I know that's not offered at a lot of people's schools. So you don't need to at all. They run through everything as though you have no kind of computer science background. Obviously, it's a little bit easier start to the year if you already know Python or some programming languages, but that's by no means a prerequisite to get onto the course.
No, I mean, that's so interesting, kind of your journey and how it has sort of changed so much, and the fact that you had to be very sort of show some strong perseverance in order to overcome what you did in order to get here. And I think it sounds like you should be really proud of to carry on and to get where you are. So I think that's a great message to sort of to share with our students. But focusing on the course, would you say that there's quite a big difference then compared to the computing IT that you sort of study at college, even sort of secondary school, compared to what it is that you're doing now? Or is it like the fundamentals kind of expanded upon, or is it sort of almost two different courses, do you feel?
Well, I would say it's kind of a mix of both, because we do two main things in a computer science course. You've got practical side of computer science that I think most people will think of when they think computer science course, in terms of learning programming languages and just kind of learning a lot of front end things, which is the things that a user will see, kind of based on what you've coded. And that's kind of, you do learn a lot, or you can learn externally, or you can learn through college courses. But then we learn a lot of theoretical computer science. And that's kind of what really sets you apart when you go into industry and when you kind of look for a career in software engineering, in artificial intelligence, in computer science, whatever it might be. So while you've got the kind of practical side of computer science, which is building upon the fundamentals that you've learned, the theoretical side of computer science, which is what teaches you to kind of this sounds very cheesy, but think like a computer and just really appreciate and understand how it works. That's what really sets you apart. So that's kind of like a brand new course for a lot of people and brand new things that you're learning.
Wow. So again, forgive me for if I'm seeing a bit slow. So at sort of secondary school, college, it's more about how to do stuff with the computer, whereas sort of now for your degree, you're sort of stepping into that world of understanding the stuff and how it works sort of behind the scenes, rather than I'm clicking my mouse, I'm starting this program, I have no idea why it's happening, but I just know that if I do this, this is what happens. It's now understanding, okay, this is why it's happening, sort of thing. Is that kind of right?
Exactly that. And that's exactly why it's so important to kind of get this extra knowledge, because it's great that you can say, okay, I type these things in and then it does that. But what if, and for example, you've got a laptop which is running, you know, a relatively powerful CPU in it, so it can do a lot of things. But then think about, okay, if you've got to build something on a tiny little Arduino with very, very limited memory, without a lot of power on it, you've really got to understand how that works and how the computer actually interprets what you've made it do to work on kind of really limited resources, or just kind of loads of different situations and circumstances. So understanding how the computer interprets what you do, as opposed to just the computer does this, it's a really important distinction, and it's really useful to learn.
And I guess also really useful to learn kind of why the things happen when they don't go the way that you intend it to. If things go wrong, it's kind of like understanding why they've gone wrong in order to make sure it doesn't happen in the future.
That is one of the banes of our existence. Is, I would say, we spend about as much time writing code as we spend debugging code, and it becomes this. One of the reasons why I loved engineering was that it was kind of problem solving, and I hadn't really thought of computer science in that way until you've got kind of you've written, say, some coursework, a couple of thousand lines of code, maybe 3,000 or 4,000, and you go through and you go to compile it and it doesn't run. So then you're going through line by line trying to work out, okay, why is this not working? You've got to really get into the mindset of, okay, what's wrong? Have I put the wrong variable in here? Is this kind of for loop running, this while loop running? All of these kind of nuances in computer science. And then you realize you've just made a typo or something like that. It can be absolutely infuriating, but there is something so satisfying about solving those problems.
No, I can imagine. And yeah, it's the fact that, you know, you've mentioned problem solving as kind of like the main feature of your course, and kind of like a big skill that you've worked on. You know, what kind of other skills have you been able to develop while studying the course? Is it just mainly problem solving, or has it kind of been like a wealth of skills that you didn't really expect?
Oh, I mean, it's really been a wealth of skills. Problem solving was definitely something that I didn't realize played such a key role in computer science. I thought it would be more kind of just learning the syntax and the semantics between with computer science. So just learning, say, for example, with Python, okay, how do you declare variables? How do you cycle through a list of things, etc., etc. But you're really just learning more about how to solve problems relating to that, I guess. But then there's loads more things that you learn that you would learn much more than you can learn Python or Java or any programming language online. But for example, we're in the middle of a team project module right now. So we've gone from our own coding style and working kind of for ourselves, I guess, to working as part of a team with different skill sets. And that it definitely has its challenges. It means you can achieve something far greater and far more impressive than you can by yourself. But learning to work with other people and learning to kind of adapt to other people's styles and manage a team of people, that has been a really, really huge thing that we've learned. As well as that, loads of kind of mathematical skills. I didn't realize just how heavily maths comes into computer science, but fundamentally, if you look at things like computer graphics, so I know there are lots of people at school that want to design games, kind of video games, things like that. It's quite a popular thing. A lot of people at my school wanted to as well. Maths is so important. I'm sure you're sitting there thinking, why do I need to learn sine and cos waves and things like that, or why do I need to learn trigonometry? It all comes into it. We've just finished a computer graphics module where you're learning about matrices, about trigonometry plays a huge role in it. So all of these different things that come and help when you just get to kind of build on these fundamentals that you've learned through school and then just apply them into the kind of computer world, which is really interesting.
No, that's, again, yeah, I think that is the big question that everybody wants to know, is kind of like trigonometry. When am I ever going to use this in life? But as you say, if it's a fundamental of game design, then if that's something that students want to pursue, then they've got to be paying a little bit more attention in maybe maths lessons to make sure that they understand it, rather than it's just the basic triangle. It does go a little bit beyond that. So that's really interesting to know. But actually, I just want to go back to another point that you raised about the whole working together as a team in order to sort of write code. I guess that's so important, because in the future, that's kind of how you're going to be working a lot of the time. Like, yeah, sure, you'll be doing code for yourself, but also there'll be times where you've all got to pitch in together and work on a piece of code. So would you say that's kind of been really beneficial to kind of prepare you for the world of work later on in your life?
So beneficial. I mean, it doesn't seem like it's necessarily the biggest step, but it is a really, really huge difference compared to just sitting working on code whenever you want to work on code, compared to working to deadlines based on kind of a project that you've got going on. You're responsible for a very specific part of what you're doing, but it all ties together. So if you kind of aren't pulling your weight, or if another team member is not pulling their weight, and then the whole team will notice it, and the whole team has to kind of compensate for your work. So there is a level of pressure to make sure that you do perform, but it really is a drive, because you're no longer just responsible to yourself, you're responsible to other people as well, which is really, it's a bit of a fire to keep you going and to keep you working hard. But for example, a lot of computer science courses will have a placement year, which is where you spend a year actually working with a real life, generally software company. So for example, I'm going to be working with Hewlett Packard Enterprise next year, and kind of throughout the interview process, I asked them about kind of collaborative work, because we hadn't done our team project module yet, so it was something quite new to me. So I asked them sort of how it works, and you do a lot of things like pair programming, which is where you're coding, but you've got somebody else either right next to you, or in COVID times virtually right next to you, looking at your screen. So as you're writing code, they're kind of checking to make sure if you've got any errors in it, what's going on. You've got kind of code review as well, which is where every time you upload your code, somebody else will then be looking at that as well, just to make sure that you've done it all right. So there is a huge amount of collaboration in computer science, which I think is really awesome, because I think a lot of computer scientists can get this kind of bad reputation of living alone in their parents' basement, which I'm sure is the case for a lot of people. But in terms of the world of work for software engineering, for computer science, there's a lot of sitting around the table, debugging things together, working together to solve complicated problems and build efficient algorithms. It's a really collaborative discipline, which one of the reasons I really love it.
No, it sounds great that, you kind of get the best of both worlds in some respects, in terms of you will get that times where you're by yourself, head down, just focusing on the work, but then other times, coming together with loads of different people to kind of work together to work on a big project and see it all come together. It will just be amazing. So thank you. I think that's sort of like a great message to send. And then I just wanted to know kind of like, what one thing about your course and about applying to your course would you like people to know? That, if is there anybody that's sort of watching this, listening to this, sort of considering applying to computer science, what is the one piece of advice that you'd like them to know?
I think kind of the biggest thing, we've touched on this kind of a couple of times earlier, kind of while we've been chatting, but it's that a computer science degree isn't just about learning a programming language. That's not all that you do, and that's not all that it means to be a software engineer, to be a computer scientist. It's about learning kind of the fundamentals of computer theory. And while theory might sound incredibly boring to you as somebody at school or in college right now, it is something that really helps you kind of just develop this deeper understanding about how computers work, and it really helps you fine-tune your coding abilities, because you learn what's efficient. You learn, that's what differentiates you from somebody that's learnt to be a software engineer from a course online, compared to somebody that has actually sat there and learnt things like, I'm going to throw some jargon at you, the pumping lemma and things like that will actually help you become a better software engineer and be that step above everybody else that hasn't done that bachelor's degree. So these are the sort of things that are sought out by companies like Google, like Amazon, like Netflix, like Apple, all of these huge companies that will give you an incredibly comfortable life in the future if you work for them. They're looking for that thing that differentiates you from other people that know these programming languages, and doing a university course in computer science is exactly that.
I know, amazing. Imagine working for a big company like that. Just think of the perks of working for Netflix. Free Netflix for all your life. Wouldn't that be good? But
That's all you need, really. Although your salary just goes to Netflix anyway, so you might as well just work for them.
exactly, exactly. And then my final question before we wrap this all off is, for you personally, you know, I think you've got 2 years left, or yeah, your placement year and then a year after that, by the sounds of it. So once you graduate, kind of what's the next step for Jeremy? What do you see yourself doing, or what do you hope to see yourself doing?
Oh, that's an interesting question. So there are so many paths that you can go down with computer science. You can, of course, go into artificial intelligence. You can go into data mining. You can go into just standard software engineering. You can go into project management. There are loads and loads of different paths that you can go down. It's hard to know exactly what you want to do, but I really like the idea. I love working with people. I think that is one of my kind of biggest drives to work for a company in the future, is just kind of the social aspect of it. And I also just really love kind of the nitty gritty and getting down to code and writing stuff. So just being able to work as kind of a technical project manager or something like that, where you can marry together the social aspects of work and managing a team and working with people alongside the problem solving and the coding. If I can find a job that marries them together, I would absolutely love that.
I mean, that sounds like a dream come true if we can sort of, if you can indeed get to that point. So I wish you all the best with it. It sounds like you should be more than capable of doing it, and just hope it goes well for the rest of this year, and then your placement year, and then the dreaded final year. I'm sure you'll absolutely smash it. So on behalf of the Pathways team, I want to thank you for speaking with us today, and wish you the best of luck for the future.
Thank you ever so much. It's been a pleasure speaking to you.
No, thank you. And for you guys listening, hopefully you've kind of learned a lot about Jeremy and about his course, and hopefully find it a little bit interesting and want to find out more. Please do head to our Pathways website, check out our other World of Work videos, and also do your research. If it is something that you're interested in, make sure that you sort of go to the relevant sites and find out more information, so that you can help make the choice that is right for you. But that is everything from us right now, and I hope to see you all soon.
Thank you.